This is part 7 of the series Transformations, and in this part we're going to talk about dilations. This is the fourth type of transformation that we've been dealing with. Up to this point we've dealt with congruence transformations, translation, reflection, and rotation. A dilation is a geometric transformation in which the distance of each point in a figure from a fixed point called the center of dilation is increased or decreased. What that means is, specifically to dilate means to get larger, but in geometry, a dilation can mean enlargement or reduction of a figure. So it's talking about the distance a figure moves away from a given point. So in this case, we have triangle ABC and triangle A prime, B prime, C prime. And we can see that the x-coordinate of A goes from 2 to 4. And the x-coordinate of B goes from 2 to 4. And the x-coordinate of C goes from 5 to 10. So you can see that all of those x-coordinates have been doubled. Now that gives the idea of what's known as scale factor. And the scale factor is a value that determines how far the points of a figure are moved, and they're moved from a point called the center of dilation. Now, think of the center of dilation if you've had experience with any kind of drawing, mechanical drawing or artistic drawing. You can think of the center of dilation as what's known as a vanishing point. So all of the points in a figure that are dilated, they're moved along a line taken from the center of dilation through the initial point of the pre-image. So if we were to draw a ray away from the center of dilation through the pre-image points, you would see these dotted lines. And the points of the image after dilation are going to be somewhere along those lines. So that's the idea here. Now again, scale factor determines how far the points are moved away, and we can have two different types of scale factors. If the scale factor is greater than 1, we call that dilation an enlargement. So if a scale factor, if a figure is dilated with a scale factor greater than 1, we call that an enlargement. In this case, since we have a pre-image that's smaller than the image, this figure represents an enlargement, a dilation with a scale factor greater than 1. A reduction occurs when we apply a scale factor between 0 and 1. So a reduction is where the points of a figure are getting closer to the center of dilation than the points of the pre-image. Now let's look at some dilations in real time just so that we fully understand what's going on here. Here we can see we have figure ABC, triangle ABC, is being dilated to A prime, B prime, C prime. And up here you can tell that we have a scale factor of 2. So this is an enlargement. And notice how the points are all on this line. And the A points are on this line and the C points are on that line. Now as I change the scale factor, watch what happens. As I make it bigger, the points of the image move out along those segments, and they move with respect to the center of dilation, point P. So this point P. Now notice the scale factor is between 0 and 1. In this case it's 0.3, which is less than 1. So it's a reduction. So the image is smaller than the original. When we make it a little bit bigger, and as the scale factor approaches a number greater than 1, it's an enlargement. Alright. Let's see what happens when the scale factor becomes negative. If we go down smaller and smaller and then we go negative, you see that the figure moves away but in the opposite direction. And so here we have a number that's greater than -1. So this is an enlargement, but it's an enlarged in the negative direction. So the figure is basically flipped. This is on the top, this is on the left, and now it's on the right. So the figure is flipped or reflected. And so when the figure goes negative, we're still moving along these segments, but we're moving in the opposite side of the center of dilation. So that's what happens when we have a scale factor that's negative. Now, in addition to all this, we won't just always dilate with respect to the origin. If we happen to have a center of dilation that's different than the origin, what ends up happening is the dilated values move with respect to that center of dilation, not with respect to the origin. What that's going to imply as we get to the point of actually doing these dilations, we're going to actually have to account for the offset of this center of dilation from the origin in order to actually be able to calculate this dilated figure. And that's going to make our calculations a little bit more complex, but it's not too terribly bad. We'll go through a couple of examples. So just understand that these figures are dilated with respect to the center of dilation, regardless of where it is. In the initial cases, the center of dilation is the origin. And that makes for a very easy calculation, but it's not always going to be at the origin. What I'd like to do now is take a look at some coordinate rules that are going to help us move through the calculations for dilations. So what I'm going to do is I'm going to turn on the display of the coordinates for point A and A prime. Now here we have a dilation with a scale factor of 2 about a center of dilation, which is the point 0, 0. And notice what happened. We take the x-coordinate and we multiply it by the scale factor to get the dilated x-coordinate. We take the y-coordinate, we multiply it by the scale factor to get the dilated y-coordinate. And that's all there is to it. It's a very straightforward process. That's all we're doing is multiplying the pre-image points by the scale factor to get the image points. So whatever your scale factor is, whether it's 1.5, 3.2, whatever it happens to be, you multiply each x and y coordinate of your pre-image with that scale factor to get your image points. Now let's look at what happens when our center of dilation is offset. So let's move this 2 units in the x direction and 1 unit in the y direction. Let's take a look at what happened to the x coordinate first. Now clearly you can see that the x coordinate isn't 4 times 2. So something else has happened here. Now what's happened is we had to account for this offset. Notice the x coordinate is offset by 2 units from the origin. In other words, the x coordinate of point P is 2. So it's 2 units away from 0, 0. So to account for that, what we're going to do is we're going to subtract 2 from the x coordinate of the A point. And then we apply our scale factor, and then we move it back. So let's capsulize that. So what we have is we have point P with the coordinates 2, 1. We take A, which is 4, 2. And we're going to take 4, the x coordinate, and we're going to subtract off the x coordinate of the center of dilation, which is 2. We subtract that off. Then we're going to multiply it by our scale factor. Our scale factor is 2. And then finally, we're going to take and add back that 2 that we subtracted off. So let's see what happened here. 4 minus 2 is 2. 2 times 2 is 4. 4 plus 2 is 6. And that's what generated our 6. So in essence, what we did was we took that point, 4, 2, we took this point, we moved it over 2 units to account for this 2-unit offset. That was this calculation here. We multiplied by our scale factor, which dilated it, and then we moved it back the 2 units for the offset to account for the offset of that point in the x direction. Now we would do the exact same thing with the y coordinate. So for the y coordinate, we would take the y coordinate of the point, which is 2. We subtract off the y coordinate of the center of dilation. We multiply that number by our scale factor, and then we add back the offset that we took off. So 2 minus 1 is 1. 1 times 2 is 2. 2 plus 1 gives us 3. And that gives us the 3. So we have 6, 3, which is the new dilated point. And that is how you dilate with respect to a center of dilation that is not the origin. It's not that difficult. You just have to see that we subtract off the x-coordinate of the center of dilation, multiply by our scale factor, and then add it back again. Same thing with the y. Take the y-coordinate of the point, subtract off the y-coordinate of the center of dilation, multiply by the scale factor, and then add back the y-coordinate of the center of dilation. Before we go ahead and work examples, let's formalize these rules that we just came up with. Here we have the transformation notation for a dilation with center at 0, 0. We take the x-coordinate, multiply it by some scale factor s, and we take the y-coordinate, multiply by the scale factor s. It's as simple as that. Just multiply x and y by the scale factor. The dilation with center hk, we take the x-coordinate, subtract off the x-coordinate of the center, multiply by the scale factor, add back the x-coordinate of the center. Take the y-coordinate of the point, subtract off the y-coordinate of the center, multiply by the scale factor, add back the y-coordinate of the center. And that's all there is to it. So let's apply these in an example. Here we have triangle ABC. We want to dilate this triangle about the origin with a scale factor of 2. So let's go ahead and write our points. So we have A is 1, 2, B is 1, 4, and C is 4, 4. We want to dilate with a scale factor of 2. That's all we have to do is multiply each point by the scale factor. 1 times 2 is 2. 2 times 2 is 4. B prime, 1 times 2 is 2. 2 times 4 is 8. C prime, 4 times 2 is 8. 4 times 2 is 8. All right. So now we're going to plot those on this graph. And here we have our new figure. A prime, B prime, C prime. It's clearly a dilation. If we were to draw segments from these points through the origin, we would have a segment going through all these points, showing the vanishing point idea through the center of dilation. I would like to work some more examples, but I don't want to rush it. So we're going to end this part now, and we'll pick up the next part working some examples of dilations. So I will talk to you in the next part.